Okay, now question number 13. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So here in this question what they have said, that means opposite sides of a quadrilateral, okay, circumscribing a circle, that means the quadrilateral is touching the circle, okay. Subtend supplementary angles. Supplementary angles means sum of two angles should be equal to 180 degree. So that we have to prove, okay. So here you have to draw the figure. You have a circle and a quadrilateral. This quadrilateral is touching the circle, okay. Circumscribing means touching the circle. So here I have considered a quadrilateral ABCD which is touching the circle at point P, Q, R and S, okay, respectively. And what we have to prove, that opposite sides of a quadrilateral. So what are the opposite sides of a quadrilateral? Here this AB and CD, they are opposite side, right? And this AD and BC, they are opposite side. So we have to prove that opposite sides of a quadrilateral circumscribing subtend supplementary angles. That means sum of these two angles should be equal to 180 degree. That we have to prove. The first one is angle AOB plus COD. This angle, okay, AOB, and then plus this COD. The sum of two angles should be equal to 180, and similarly this angle AOD plus BOC. Sum of these two angles should be equal to 180 degree. That we have to prove, okay. So in the solution part, let ABCD be a quadrilateral touching the circle at points P, Q, R and S respectively, okay. That we have to write, and then what we have to prove, angle AOB plus COD is equal to 180 degree and AOD plus BOC equal to 180 degree. So now let us prove. So this we already know, right, that tangents drawn from an external point to a circle subtend equals angle at the center. So you see this is an external point, right, A, and this is a tangent AP and AS. So these two tangents, okay, to a circle subtend equal angle. That means these two angles, okay, I have considered angles here. Start from 1, 2, 3, 4, 5, 6, 7, 8. Total there are 8 angles, okay. And what does it mean? It means subtend equal angles at the center. So that means this angle, okay, angle 1 for this tangent, okay, AP and AS, these two angles will be equal. Angle 1 will be equal to angle 2. Similarly for this tangent BP and BQ, this angle 3 will be equal to angle 4. That I have written, okay, angle 3 equal to angle 4. Then similarly for this point C, external point C, these two tangents CQ and CR, this angle will be equal 5 and 6. And then for this external point D, these two tangents will be equal, DR equal to DS. That means these two angles will be equal. Angle 7 will be equal to angle 8. That I have written. Now you see this is a quadrilateral, right? So sum of all the angles of a quadrilateral is 360 only, or you can write sum of all the angles at a point. Okay, if you add all these angles, get 360 degree. And what are the angles in this quadrilateral? Start from angle 1 plus angle 2, 3, 4, 5. If we add all the 8 angles, we'll get the sum is equal to 360 degree. Now what do we have to prove? Angle AOB plus COD. That means this angle, okay, AOB. So in angle AOB we are getting these two angles, right, angle 2 and angle 3. So and then plus COD, and this in angle COD we are getting 6 and 7. So what we'll do is here we'll keep 2 and 3, 6 and 7, these four angles as it is, okay. This angle 2, 3 and then 6 and 7, these four angles will keep as it is, and then the remaining angle will change, okay. See, because angle 1 is equal to, so in place of angle 1 we'll write 2, okay. Similarly for 6 and 7 also will change. So angle 1 is equal to angle 2, so in place of angle 1 we'll write angle 2. This will keep as it is, and 3 also will keep as it is. We'll change angle 4. Angle 4 is equal to angle 3, so in place of 4 we'll write 3. Then we'll change 5. 5 is equal to angle 6, right? So we'll write here 6. And this one will keep as it is. Then 7 also will keep as it is. We'll change angle 8. Angle 8 is equal to angle 7. We'll write angle 7, okay, equal to 360 degree. Now see, here we have angle 2 plus angle 2, angle 3. So all the angles are twice, right, 2 times. So angle 2 plus angle 2 will be twice of angle 2. And here similarly 3 plus 2 will be twice of angle 3. Here it will be twice of angle 6, and then twice of angle 7, equal to 360 degree. So here everywhere is 2, 2, 2, 2, 2. So you can take 2 common, okay. So I have taken 2 common. So what is remaining? Angle 2 plus angle 3 plus angle 6 plus angle 7 equal to 360 degree. So here 2 is multiplied, we'll take on the right hand side, so it will become divide, right? So we'll get angle 2 plus angle 3 plus angle 6 plus angle 7 equal to 360 degree divided by 2. So if we cancel, we'll get 180, right? Now see angle 2 plus angle 3, you see in the figure angle 2 plus angle 3. So if you add these two angles, what we'll get? We'll get this angle, right? Means angle AOB. So in place of 2 plus 3, we can write angle AOB. Okay, in place of this 2, we can write angle AOB plus angle 6 plus angle 7. See this angle 6 and 7. If you add these two angles, you will get this angle COD. Okay, so let COD equal to 180 degree. That we have to prove, right? Number 1. Similarly, we can prove for this. So I don't need to prove, I can just write similarly angle AOD plus, okay, similarly angle AOD plus angle BOC equal to 180 degree. Okay, proved.